Welcome everyone. I'm Shafali Agarwal. I am a PMRF TA at IIT Madras, and this is our second TA session on the topic design of steel structure. So, as usual, first we will go whatever we have studied in this week, whatever you guys have studied in this week. We will go do an overview of that, and then we will solve some question from the previous year assignments. So in the second week, you might have studied about design of different type of connection, mainly about the bolts, two type of bolts, bearing type and frictional type of bolts, and then the what are the different type of welded connection, what exactly is welded connection, and then design of uh, fillet weld. So this is what you might have studied in this week. We will go one by one on each topic. So this we have already gone through different books and what are the different codes which you will need. For the design of connection, you will mainly need IS 800. So this is the main code which you will use for the design of connections, different type of connections. So first is the bolt connection. So about the introduction of bolt connection, we have already done in the previous week. What are the bolt connection? What are the different type of bolts? So here we will just go through the design of our bolt connection. Firstly, we will see what are the important parts of our bolt. This is our bolt, complete bolt and nut. So in our bolt, we have a shank and thread part. So two parts are there. In this, we have bearing type of bolt and friction type of bolt. So when we are doing designing, we will see bearing means friction means when we have two plates and there is a friction action between those two plates when load is applied in opposite direction. And bearing means at the surface of our bolt when due to tensile load. So these are the two type of bolted connection. Other than them, we have different joints in our bolt connection. First is lap joint. When one plate is kept over other plate and they are joined by bolts, it is called as lap joint. And in butt joint, two plates are joined end to end with new plates, and this is called as butt joint. So when we go for the design of our bolts, we have these are the important terms which we have to study, which we are going to study. First is shearing strength of bolt, bearing strength, tensile strength of bolts, and tensile strength of plates. And last is the combined shear and tensile strength. So these are the some important terminologies we have already studied in the last week. What is the gauge, and then what is the pitch and end distance, and what should be the, according to IS 800, what should be the minimum pitch, maximum pitch. All these things we have already studied in our last week. So first, now we will go for the design of different type of bolts. Mainly we will study design of bearing type of bolts. In this, as we have seen in the previous slide, first we will go for design shear capacity of bolt. So what is the shear strength? Anybody? Where shear will be there? Shear means slipping between two plates. When two plates are joined, there is a, and one plate is going in this direction, other in this direction, there is a shear force in between those two plates. So in our bolt case, we have shank and thread. So when there is a plane in the thread part, this will be termed as number of shear plane with thread mm. So sorry, this is the formula for the shear capacity. This is design shear capacity, which is equal to the nominal shear density divided by factor of safety. So factor of safety we have already studied in previous lecture. What is the factor of safety for different type of scenarios? And again, this is FUB, ultimate strength. Then NM means number of shear planes with threads. Like in this case, number of shear plane with threads is 1. Where in both sides there should be thread. Next is the area of bolt at the threaded part. So area of bolt at the threaded part is normally taken as 0.78 into area of normal diameter. This is the D. at sham. This is a D. So 0.78 of this area is taken as area at the threaded part. Next is the NS. NS means shear planes without threads. So in this case, we have two shear planes without threads. And similarly, area of sham we will take. Other are the three reduction factors terms, which will depends on our, like if we have long joint, how this reduction factor will change. If we have large grip length, how this reduction factor will change. And for packing plates, how this reduction factor is changed. So all of these terms and all these design factors are already present in clause 10.3.3 of IS 800. Similarly, when we go for the bearing capacity of wood, that was shear capacity. Shear capacity means when it is acting on the two plates interface. Now, bearing capacity means this is a bolt and these are different plates. So, between this point, the cross sectional, the lateral section of our bolt and the plate, this circular section and plate, that is the bearing capacity of our bolt. So, this bearing capacity, this can be calculated. This is given in clause 10.3.4. It is calculated as 2.5 kb dt fu. Again, different terms are there, where V and B is the nominal bearing strength. Then Fu will be the ultimate tensile strength, and D is the diameter, and this is the, T is the thickness of the connector plates. Okay, like in this case, it's given. So this is a plate, so this will be a thickness of the connector plate. Okay, and KB is the factor which can be which depend on these terms. It can be E by 3D, 3D naught. D naught is diameter of bolt hole. There are two diameters. One is D. D is the diameter of bolt. This one. And D naught is the diameter of bolt hole. That means this one in the plate which we have. Okay. So this is the nominal bearing strength. If we have to again go for design bearing strength, then we will divide it by the factor of safety. Okay. Third point when we go is, you have any doubt? You can ask.
Yes. Yeah,
Hmm.
can you hear me? Are you able to hear my voice?
Yeah, I can hear you.
Okay, can you go to the previous slide and design of bearing? Yes. Uh, so here, I mean, uh, the bearing is seems to be like same as like a crushing or some kind of pushing the bolt into an
Another.
I mean, I was not able to completely define it. I was to seeing the pictures, I can understand it's kind of crushing it. But at the same time, but when the load is applied, not only the bolt, also the plate takes some kind of uh, energy, I guess, because even the plate goes some deformation, I guess. So is that how is that considered when calculating the I mean, bearing capacity of that bolt? Because even plate takes some force, so how is that happens?
As of now, we are just designing our capacity of bolt. In this case, how we are including our plate is like this T, T normally thickness of our plate only, thickness of
Okay.
plate. And then when we are calculating KB, then we are taking diameter, the diameter of bolt hole. That bolt hole will be in plate section only. This way.
Then in this case, then there is no consideration of bolt strength in that way. I mean, we have not used the ultimate strength of the bolt. We have used only the plate ultimate strength, and we are calculating the bearing strength of the bolt. I mean, are getting my concern
Yeah. We are only, even FU, we are taking off the ultimate
uh,
strength of plate only, not of the
yes,
bolt.
yes.
So, okay. So then next point is the tensile capacity of bolt. So in tensile capacity of bolt, what we are taking, we are calculating the tensile capacity, which is 0.9 FUB A and B. So here we are taking ultimate strength of our bolt and net tensile stress area. So in this case, tensile area, it will depend on different terms as it B, N, and D. With it will again depend on the plate systems. Like B is the width of plate, D naught is the diameter of our plate, and T is the thickness of our plate. And uh, N is the number of holes along with perpendicular to the direction of hole. So all of these terms depends on a plate system. So here ultimate stress will be of bolt, but area will be taken according to our plate system. Okay. Next thing is when we have combined shear and tensile capacity. It's mostly in cases like this when we have attached one column with bracket. In this case, we are applying bolts here, and because of the loading from this side and uh, this area, we will have shear capacity. Sorry, load is applied in this direction, so there will be a shear capacity here, shear stresses here, and because of this continuous load, this plate will try to move in this direction, which will cause a tensile stress to our bolt. So in this case, we will take the combined effect of tensile and shear capacity. So this is the formula which we are taking. And last is the strength of our solid plate. Not if we have any solid plate, how we will calculate its strength. It will depend on the stress, ultimate tensile stress of plate and width of plate and thickness of plate. So how where the strength of solid plate is usually required is when we have to calculate the efficiency of our joint. Okay, strength of solid plate, purpose strength, and strength of joint. Strength of joint we can calculate from these different terms which we have already used, like shear, bearing, and tension. And the strength of solid plate will be given by this term. So when we have to calculate efficiency of our joint, we can use these two terms. So this is what is there in the design of bearing type of bolts. Next is the different failure modes of plates in bolted connection. So if we go to the bearing failure, uh, this is one plate, this is our first plate, and this is our second plate. When load is applied in the opposite direction, what is happening? There is a tearing of our plate. So this is called as bearing failure of our plate. Okay, like you can imagine two plates are going in this direction. So there is some marks on our plate. The bolt will try, sorry, bolt will try to move in one direction. That will cause us bearing failure of our plate. Second is shear tear out of plate. When the failure is in this direction, like a complete plate is tear off from one point, like a single point is tear off in the lateral direction, that will call as a shear tear of our plate. And next is the tension failure. Tension failure means due to all the bolts in the single line or in one direction, there will be a this this plane will be a weaker plane, right? Because of too many holes. So along this weaker plane, when there is a complete failure, then we will call as a tension failure. Last is the block shear failure. Block shear failure means when two plates are connected, when all the joint lines, not only in one direction, in complete direction, are completely detached from the below plate, that will call as block shear failure. Means complete this part will be detached from the previous plate, that will be a block shear failure. Okay. Next is the friction type of bolt. So first we have seen the design of our bearing type of bolts. Second is the friction type of bolts. So normally, mainly we are concentrated on high strength friction grip bolts because those are the type of bolts which we are currently using. So again, same procedure we are following. First, shear strength. In shear strength, we are one thing which is different from our bearing type of plates is Here our coefficient of friction will be added in all terms. So I think other terms will be almost same. The nominal shear capacity of bolts will depend on the coefficient of friction. KH is the coefficient for clearance hole, and F naught is again is the proof load. Proof load is a type of tension load which is included in frictional gives both. So if when two things are joined and there is a like these two plates are joined with a bolt, we have a frictional stress over it, sorry, tensile stress over it. So along with tensile strength, because of friction, we have another type of force on it, which is called as stress on it, which is a proof stress. It's almost similar to the tensile strength, but an additional tensile stress, which we are considering in case of our frictional bolts only. Okay, so this is our shear strength of bolts. Next is the bolt and bearing. So in bearing, again, we are taking, it's almost similar to the bearing in normal bearing type of load. So we are taking nominal bearing stress, ultimate tensile stress of bolt only. D will be the diameter of bolt and T will be the thickness of our plates and Fu will be the tensile strength of bolts. And similar, these terms are similar. KB constant is the similar. In tension, again, we are in tension is this is the formula where the tensile strength of the bolt is given by 0.9 FUB A and B. FUB is the tensile strength of stress of bolts, and A and B is the net tensile stress area of bolt. So in this case, A and B is the if we say what do you think tensile stress is usually applied in this direction? So when we have to take next tensile area of bolt, we will take this area. This area means pi by 4 d square. Okay. And ASB the shank area. Shank area means this lateral area. Because this is our shank part. So ASB will be given by this area. So this is what is defined as bolt and tension. And last, again, we will design the shear and tension. Similar case as we have in bearing case, we will consider both shear force as well as tensile force. Okay, this is all about the design of bolts in bearing and friction. If anybody have any doubt, you can unmute yourself and ask. And you have any doubt? It's okay. We
Hello.
will. Hello. Yeah.
Yeah. Actually, I have some doubt in the concept.
Yeah.
Generally, it is preferred that these HSFG bolts are designed very much with high friction resistance. So, do then why do we still calculate the bearing strength? I mean, is it necessary?
It's necessary because when we have to give a final design result, when we are taking smallest of two, either smallest of shear strength or bearing strength. So if we have to design it fully, we the code says that it should be smaller of either bearing or shear strength. So that's why we are calculating bearing strength also,
So that means there is still a possibility that it
that it
can
can
fail
fail
in bearing
bearing.
also.
Yeah.
Okay. Okay. Thank you.
So next is the welded connection. So I think that is the most common type of connection we have seen in now in current scenario is welds. Everyone must be familiar of these type of welds. So we have different type of welding processes: forge welding, hermit welding, gas welding, resistance welding, and electric arc welding. So these are not as important to you as we have the design of weld. So this is mostly terms related to when we go for the mechanical engineering. So these are the few advantages and disadvantages of a weld connection. Like for the bolt connection and rivet connection, we have already seen advantages and disadvantages in the previous session. So here we will go for the weld connection advantages. So mostly we don't need any hole. So there is no area reduction. There is no chance of failure in shear, bearing, and tension because of the holes. So it's more effective in taking the loads. And next is in welding, filler plates, gusset plate, connecting plate are not used, which reduces the overall weight of our structure. Simply two things can be connected using a weld connection. So we don't need an external plate to make a connection. So that will reduce our weight of our structure. And these are more economical as less material is required. Efficiency is more. Efficiency, how we are calculating efficiency in bolt cases? Strength of our bolt divided by strength of our plate. So in this case, we'll see how we will calculate the efficiency. So mostly efficiency of our welded joint will be more than that of rivet or bolt joint. And it look aesthetically it is looking better than our rivet or bolt joint, and speed of fabrication is faster. Last is complete rigid joint can be provided. We can easily alter our existing structures as compared to rivet joint, because if we have to alter a rivet joint, we have to complete the plate have to be completely failed. Sorry, completely destroyed to make a new connection. But in this case, we can just cut the part and join a new part. And during the welding, noise is not there, whereas during riveting, we have to use hammer and all, then which will produce more noise. And the welding process required less workstation as compared to riveting. Any shape of the joint can be made with ease. So even if we have circular thing, we can join them with the um, weld joint, but it will be difficult when we have to go for the rivet or bolt connection. However, some disadvantages of welding joint is they are brittle, so they will cause a point of failure. That in our complete member, if we have weld joint here, that will be our point of failure, like maximum stress will be at this joint. And due to uneven heating cooling during welding, member may distort, and skilled labor is required, electricity is required, and no provision of expansion and contraction is kept in welded joint. So if we are welding 2 points, there is no chance that we can keep it for the expansion and contraction. For example, if we take the rails of our railway, we are normally giving us some space to two rails and joining them using a plate. So in this case, we are giving a space for some expansion and contraction. But if we have to join these rails using the weld, we have to join them fully. So there is no gap for expansion and contraction in case of welded joint. Inspection of welding joint is more complex and costly, and small defects at micro level like internal air pocket or incomplete penetration are difficult to detect. Also, if we go for the corrosion thing, if there is any gap, if imagine this is full with welded joint and there is any air pocket here like this will create a point of where which can start the corrosion of our two plates. So this can be a dangerous thing from the durability point of view also. However, if we see our other bolt joint and rivet joint that are also the cause for corrosion as we have studied in our previous lecture. So, but this we'll say at micro level, if there is some issue with our joint, that can be more detrimental. Okay. Next is the type of welds which we normally see. We have fillet weld and butt welds. So in fillet weld, we are connecting two plates like in L section or at any angle using we are welding two plates in this direction. In butt joint, we are normally joining two plates in a parallel direction in the same direction. So this fillet weld, we in term of butt weld, we have different type of butt weld. First is square butt weld. In square butt weld, we are just joining two plates and filling it with the weld. Next is single V butt welds. In single V butt weld, we are making a V groove in our plate and then filling it with and then welding those parts. Other are double V butt weld. Double V butt weld. Again, we are making some V shape of in our metal surface and then filling it with the weld. And next is single U. It all depends on the shape of your weld. Normally, these names are depending on the shape of the weld. W or single U, then W, then single bevel butt. So one big plate is there and other plate is there. So in this case, two plates are of different size. So, and we are filling it with this type of weld, and that's why we are calling it a single bevel butt weld. And in double bevel butt weld, we are filling both look same only. I think that figure is wrong. We'll see to it. And this is J butt weld. In J butt weld, we are making a groove in one plate only, other plate will be straight, and double J butt weld will be this and double bevel have only the difference of shape. The shape is a little bit pointy in case of bevel belt, and in case of J belt, it is curvy. So these are the different type of bolts depending on the shape. Sorry, different type of butt welds depending on their shape. So when we go for designing, in this week we have only done designing of fillet weld. So we will quickly see what are the important terms of our fillet weld designing. So as we have seen, a fillet weld will be two plates joint at 90 degree or at any angle. So in this case, some important terms are we are calling this part as leg part, and this corner of our weld will be toe, and this is our welding face. From this point of view, if we are seeing, this is our welding face, and this complete joint area will be called as the fusion zone. And at the edge of two plates, the point where weld is there, it is called as root. So we have some important terms. The point where our weld is joining one plate is toe. The point where our weld is joining both plates is called as root. Okay. And from the point we are seeing, it is a weld face, and other complete region is called as the fusion zone. Okay. So important term when we come for the designing of our fillet weld is what is the size of our fillet weld, and throat of fillet weld, effective length of fillet weld, end return, and overlap, side fillet, intermediate fillet weld, single fillet weld, permissible strength of fillet weld. So we will see each term individually. First is the size of weld. So if this is our have this L type of fillet weld. These are our two legs of fillet welds, and the size of a minimum leg length. So one length is this, other is this one. The leg length 1 and 2. So minimum these two are called as size of weld. So this is the table given in IS 800. From there, you can get the minimum size of weld. It will depend on the thickness of thicker part. So this is normally what is called as the leg of our weld. So minimum of these two will be called as the size of our weld. Next is the effective throat thickness. So if this is our fillet weld, and if we draw a straight line, and from the corner to this point is called as throat thickness. So this BT we can using our normal mathematical uh, calculation, we can calculate this T part, right? In this case, we are considering BA is equal to BC is equal to S. We are considering both lengths are equal. If we consider both lengths are equal, we can easily calculate this BT value, right? From right angle to angle properties. If we have BA, BS, we can calculate AC. And from AC, we can calculate in this triangle, in one triangle, we can calculate this part BD, right? Like AB's, from this triangle, we are calculating AC, right? Then we will go to the triangle A, D, and B. In triangle ADB, this is our right angle. So AB square will be BD square plus AD square. From Pythagoras theorem, we can calculate this. And AB we already know is S. So BD we can calculate. BD is our throat length T. So BD will be S square minus AD square. S square minus AD square. So this complete term is under root 2S AC. So AD will be half of this term, right? Square and normal Pythagoras theorem we can use and calculate the throat thickness. So normally throat thickness is taken as 0.7 of S. This is the ideal case where our both leg lengths are equal. In case if they are unequal, then we again have to calculate it fully. Like AC, we have to calculate that this both part won't be equal. So that thing will become in the designing of fillet weld. Next point is the effective length of fillet. So effective length is overall length minus 2s. This is our effective length of fillet weld. So effective length will be calculated as overall length minus 2s. S as we have seen this part. This will be our S. So total length minus 2 times F will give us as effective length of fillet. Okay. Next is the strength of fillet weld. I think this is it will be these two terms will be coming here. P gamma MW. FU will be the ultimate stress. LW is the length of weld and T is the thickness, and M and W are the different constant which we will be using further. Okay. So this is what you might have studied in the previous week. So we will solve some, I will give some questions to you. You can reply the what do you think is the correct answer in the chat box, or you can speak up also. First question is, if D is the nominal diameter of bolt and D no is the corresponding standard hole diameter, the length of bolted joint LJ is known as the largest joint. If so, in bolt joint we have seen three type of joints, large joint and two more joints. So where we were telling about reduction factor. So when we will call it as a large joint, if LJ means length of bolted joint is greater than or equal to 8D, or LJ is greater than equal to 8D naught, LJ greater than 15D, or LJ greater than equal to 15D naught. Anybody who want to reply? So this is given in our IS 800 only. When the length of joint will exceed 15D, then we are calling it as a long joint. Okay, I think we here also we have it. So for long joint, we are telling if length of joint is greater than 15D, then we will call it as a long joint. Okay. So these are the questions which you can easily found in IS 800 and solve. The answer will be C if LJ is greater than 15D. Is this part clear? Next question. Maximum size of fillet weld done to connect an ISO 90 into 60 into 8 with a gauge plate is. You have to solve this question. I will give you 2 minutes time. These are in the sir's lecture also. You might have done one example in his class. There you might have find the maximum size of fillet weld. You can see from there also. Is 6.5 mm. Actually B. So the maximum size of fillet weld is given by 3/4 of nominal thickness. In this case, our nominal thickness is 8. So 3/4 of 8 will give us 6 mm. So maximum size of fillet weld will be, in this case, is 6 mm. Okay. Okay. Next question. If size of fillet weld is 5 mm and angle between fusion faces is 90 degree, then what should be the minimum end return provided? So this is our end return normally. How would you calculate this thing? Also given in his lectures only. You can find out. So end return is normally twice of the fillet weld. So end return should not be less than twice of the size of weld. In this case, size of weld is given as 5 mm. So our end return will be 10 mm. Okay. These are the type of question which you will see in your assignments mostly. So please try to participate quickly. Next question is prying force in high strength friction grip bolt used in joint or connection becomes significant if. So this we will seeing in our friction type of bolting. We are adding one more term is prying force. In this case is Q, which is a type of tensile force only, an additional tensile force that is called as prying force. So when will it become significant? When a member connected with the HSFG bolt possesses sufficient flexibility, or HSFG bolts are flexible enough, or member connected with bolt possesses sufficient rigidity, or member connected with bolt possesses very high mass density. Anybody who want to guess the answer? A. Okay, correct answer. So in IS 800, this is the definition of prime force, which is given as additional tensile force developed in bolt as a result of flexing of connection components such as beam and plate of end plate or leg of an angle. So when our bolt is possessing flexibility, flexing of our connection component in our here our component is bolt. So when our bolt has sufficient flexibility, that time we can say our prime force is sufficient enough. Okay, significant enough. Sorry. Next question. What should be the value of constant K?
Excuse me,
Yeah,
I have a doubt. Can you please switch to the previous questions? Yes, here option B it's mentioned as the bolt should be flexible, but option A is the member connected member is flexible. So what should be flexible? Is it the
sorry.
member or the bolt?
It should be the member. See here the flexing
Okay,
of the connection components such as beam and plate or leg.
okay, okay, right. Yeah, thanks.
Okay. I think I have said it wrongly.
Yeah,
Sorry.
that's it. Thanks.
Okay. What should be the value of constant K in calculating throat thickness of fillet weld if angle between the fusion faces is 104? Try to calculate if you want. K, okay, 0.7. So this is given in IS 800 directly. So here we are telling 104 degree. 104 degree will come here. So won't be, angle is 104 degrees. So our K value would be 0.60. Okay. Next question is shear capacity of a bolt is given by VDSB and bearing capacity is given by VDPB. Strength of a bolt or bolt value is given by VDSB, VDPB, minimum of both or maximum of both. I think this is very easy question. How strength will be given by one type of capacity? I think we already discussed it also. So it's C correct answer. So it will be given by minimum of both type of capacity. So here it is given in clause 3, 10.3.2 also. It is taken as the smaller of the both value. Okay. Next. As per IS 800, bolts subjected to combined shear and tension should satisfy which of the following conditions? This is a direct formula which is given in IS 4. You can check and see. D. Okay. So combined shear strength is given by VSF by VDP square plus TF by TDF square less than 1. Correct answer. Next question is two plates of thickness 16 mm and 18 mm are connected by fillet weld in shop having throat thickness of 5.6 mm and effective length of weld is 700 mm. Calculate design strength of the fillet weld. So this is the formula. If you want, you can take 2 minutes and try this out. So design strength will be given by ultimate strength divided by partial safety factor. In this case, our partial safety factor will be 1.15, right? Now we have to calculate the ultimate this sorry normal stress, nominal stress, which will given by ultimate stress divided by under root 3. Should I start the solution or anybody is trying? Okay. So this is the partial safety factor. So in our case, we are taking 1.1, sorry, not 1.15. Next is the design strength of fillet weld. Here, the small f will give us stress only. So we will multiply this permissible stress by effective area of weld, which will give us the strength value. Okay. So Fu divided by under root 3 divided by gamma WA into area of our weld. So in this case, Fu is already given as 410. Fu is 410 and gamma MW will be 1.25. 1.25. This is for welding, it is 1.25. If it is shop fabricated, that's why. Sorry. It's shop fabricated and it is a weld joint. So our gamma MW will be 1.25 and then effective area of weld will be taken as LW. LW is our effective length of weld, which is given as 700 mm, and TE is thickness of our thought thickness 5.6. We will multiply all these terms and then we will get the strength approximately near to 742 kilonewton. Does anybody have any doubt in this question? If there is no doubt, then we will go to the next question. The strength of a bolt is obtained as 65 megapascal. If correction factor for long joint, grip length, and packing plates, these reduction factors we have seen in the first slide of our bolt joint, are given as 0.9, 1, and 0.8, then what will be the corrective strength of bolt? Our normal formula. Here, this is a nominal shear strength, which is given by Fu upon under root 3 and A and B values. Already this term is given to us as 65, right? It's complete, sorry. This complete term is given to us 65, 46.8. This complete term is our 65. Then, then we have correction factors, BLG, BLG, BPK. We will multiply all these factors and then we can get the value. In this case, it will come as 46.8, correct answer. So, next question. 20 mm nominal diameter bolt is used for lap joint of two plates of size 16 mm and 18 mm. The edge distance, pitch distance, and the ratio of ultimate strength of bolt material to plate material is given as edge distance is 35 mm, pitch distance is 50 mm, and ratio of ultimate strength is 0.98. What would be the coefficient of bearing KB for calculating bear strength? So I'm giving you the formula. We have this design bearing strength, and this is the formula 2.5 KB dt Fu, and KB is given as smaller of E upon 3D naught, P upon 3D naught minus 2.25, FUB upon FU or 1. So from these value, what do you think will be the value of our KB? You can calculate it. We'll go this step by step. First, we have the diameter of bolt, which is already given as 20 mm. Okay, nominal diameter. And for the value of KB, we require diameter of our hole. And we are considering the nominal clearance. Nominal clearance is 2 mm. So from there we can calculate D naught, it's 22 mm. Can I take IS code in exam? I'm not sure. I have to confirm it with the PMRF team, then I will let you know. But normally, I think you can take your IS code. I will tell you in by next class. Okay. So we can calculate D naught value. Then we have, what are the terms we have? E. E is the end distance, edge distance, sorry. So edge distance is given by 35. So first time we can calculate 35 divided by 3 into 22. Second is the P upon 3D naught minus 25. P is our pitch distance, which is given as 50 mm. So this term also we can calculate. Last is the FUB upon FU. This is already given as 0.98, 0.51. Okay. So we'll take minimum of these terms. Correct. So when we are calculating all these four terms, the minimum value which we are getting is 0.51, as we have already calculated. Next question is, calculate the design shear strength of ordinary bolt of nominal diameter 20 mm and grade 4.6 under double shearing condition, one shearing plane intercept at shank portion and other at threaded portion. The size of two connecting plates are 12 mm and 14 mm, assuming Fe 410 grade of steel. So what we are telling it's a double shearing. So it's a double shearing thing. This is the question. And this is the formula which you can use. You have to calculate design shear strength. Now we have the nominal diameter as 20 mm and grade 4.6. So from this grade 4.6, we can calculate our FUB value, right? And from this nominal diameter, we can calculate our A and B and ASB. So there, sizes of connecting plates are 12 mm and 14 mm. So if it's a double sharing, and assuming F10 grade of steel. First, you guys try. I will give you 2 minutes. Then we can start the solution. Let me start it. For 4.6, I think we have already studied about this. If 4.6 is there, then this 4 will represent our ultimate strength of our bolt. So 4 will give us ultimate strength as 400, and this 6 will give us a ratio of ultimate strength to the yield strength. 0.6, sorry, yield strength to the ultimate strength. And so FUB will be 400. Then for FE10, FU will be 410. Now D is given as 20, D naught is 22 mm. Next is we have to calculate these different terms. So FUB is there, gamma and MB is already we know. In this case, it will be 1.25. Next is the shank area. Shank area is directly pi by 4 into d square. And for the threaded area, it is 0.7 of shank area. So these two areas we have calculated. And if it's it's already given as double shearing. Double shearing condition means we have one shear plane at threaded position and one shear plate at shank position. So NN as well as NS will be 1. Okay, so we have all the terms with us and then we can calculate our design shear strength, right? You can see the solution for 2 minutes. If you have any doubt, you can ask me.
Can how many plates are connected in the figure shown? Is it 2 plates or is it 3 plates or is it 4 plates or?
In the figure, 4 plates are connected, but
Okay, so we have 3 shear planes then.
we have 3 shear planes. Sorry. Yeah, I think the figure is wrong. It should be 3
Okay,
plates and one at the threaded point and one at the shank point only.
okay, okay, right.
Mm.
Thanks. And one more doubt. This is not in relation to the question. We have this complete joint penetration weld, right? CJP and PJP and all. Is how do we differentiate between a complete joint penetration weld and a butt weld?
How do we differentiate between complete joint
A butt
penetration?
weld and a butt weld.
I have to go back. The complete joint penetration weld, I have not defined, I think, right?
Yeah. But in the field, in real case scenarios, CJP and PJP are widely used, right? So that's what got me thinking.
I don't have any idea about it. Maybe I can tell you
Okay,
by the next week.
sure, not a problem. Thanks.
So, this question is clear to everyone, right? We will go to the next question. Two plates of thickness 10 mm and 12 mm are connected using HSFG 8.8 grade bolts of 22 mm diameter. Calculate the proof load. So this is the given in clause 10.4.3. And proof load is given by A and B into F naught. And A and B is the net area of bolt at thread, and proof stress is given by 0.7 of FUB. Okay, you can try the solution. Firstly, how we are calculating our FUB. This is for our FUB. As for 8, this 0.8 will indicate our FUB value, and 0.8 will be indicating our ratio. Okay, so FUB will be 800. What is unified FUB? Then you can calculate F naught and A and B. Area you can easily calculate. Net area of bolt, that will be 0.7 into normal A and B. ASB, sorry. 0.78 into ASB. Proof load will be given by A and B into F naught. A and B is 296.5 and F naught is 0.7 of FUB. In this case, our FUB is 800. Okay. Simple question. I hope it's clear with everyone. So this is the last question for today. Consider the problem stated in question 12 where we have calculated our proof stress. Calculate the design shear stress force for the bolt if slip resistance is designed ultimate load and assume fastness and clearance hold. Take coefficient of friction as 0.5. Number of effective interface of frictional resistance is 1. So in case of slip resistance, how we are calculating our design forces, VNSF divided by gamma MF. Again, gamma F will be our partial safety factor, which will be defined as 1.25. And to calculate VNSF, we have this formula, mu F, coefficient of friction, which is already given as 0.5, and number of NE, number of effective interface, which is given as 1. Other terms are KH and F naught. F naught we have already calculated in our previous question. How much it was coming? It was 166, right? So F naught is 166. Last term which is left is KH. So how based on our based on different terms, you can find the KH value, and in this term, our KH constant will be 1 only, because I think it's already given shear. So if the slip resistor the ultimate load and assume fastener in the clearance hole. So for this term, we are taking KH as 1. So we will just divide it by 0.5 and we are getting 83. And design force, we will divide it by the partial safety factor of 1.25, and our final design shear force will be 66.4 kilonewton. Okay.
Yes. Uh, Regarding the value of NE, it was given that number of effective interfaces offering frictional resistance to slip is 1. Like, what exactly in general, according to the problem, I understood it. What is this actual surfaces which you resisting to the bolt? Like, is it related to number of bolts, or how exactly
Number of
we define it?
plates. If we have two plates, then our number of effective interfaces will be 1.
Okay. So can you give an example of where it can be 2 or 3?
If our number of plates are 3, then wait,
Okay.
I will show you one. In one question, we have seen where we have 4 plates. Yeah, this one. So in this case, our number of effective that plates will be 3. NF will be 3.
Okay, this is kind of shear resistance where the
Yeah.
section. Okay, resistance shear, right?
So that's all for today class. If you have any doubt or any suggestion for me, you can either put in the chat box or you can mail me on these IDs. And about the IS code, I will clear that doubt by next session. I will ask the team if you can take the IS code or not, and I will reply.
Also, I have one more doubt. This is regarding to the lectures. So, do you have any access to the PDF PPTs shown in the lectures?
Yeah, I have the PPTs. I think you will get the under lecture materials, you will get the PPTs.
Yes. I mean, I have a doubt in one particular clause. I mean, it was mentioned after size of weld, kind of in a note. So they were saying like clause 10.5.1 about deep penetration welds.
Wait, I will just check it. In SIR's PPT you are telling, or in IS code you are telling?
In SIR's PPT.
Yeah.
Uh, please go to the size of fillet weld. To the slide size of fillet weld.
This one?
Yeah, I mean, go on like 2 more slides. Yes. The blue color paragraph, like as per clause 10.5.1, 5.2.1.
For
So can
deep
you explain that part, that particular para?
as per clause 21, for deep penetration wells, where the depth of penetration in the root run is a minimum of 2.4 mm. The size of the fillet weld is minimum leg size plus 2.4 mm. Here they are telling uh, so it's saying for deep penetration well, where the depth of penetration beyond the root run is minimum 12.4 mm. Deep penetration where the depth is beyond 2.4 mm. Okay, so this is a root. Okay, so it's saying if our root part is beyond 2.4 mm of this part of this is our throat thickness, right? With the
Yes, the
indication here.
diagonal one.
So if we go by this line, so this is a normal part of two plates. They're telling if this root part is very deep, in case if it is more than 2.4 mm, this part is more than 2.4 mm. In that case, we are taking our size of weld as leg plus 2.4.
Okay, okay.
If this is more
And
than 2.4, then we
yes,
are calling this at deep penetration. That case, we will take a, sorry, you were telling something?
yeah. So this is the criteria where we differentiate penetration and deep penetration kind of thing.
Yeah. So if it is less than 2.4, we can call it as shallow
Penetration.
penetration maybe. And
Okay.
if it is more than 2.4, we can call it as deep penetration.
Okay. Okay. Thank you.
So there is no doubt, then we can close the class for today.